Hello everyone, welcome back to My Chem Corner. So in today's video we're going to talk about another chapter in physical chemistry class 12, which is solutions. So if you're new to this channel, please don't forget to hit the subscribe button and also the bell icon so you receive further notifications as and when I upload a new video. So let's move into the chapter. So in this chapter, what are the contents that you're going to look at? What are the main topics that we're going to focus on? So when we start the chapter, basically we're going to start with respect to introduction of solutions, what are the different types of solutions that you can come across. And whenever we look at solutions, the main thing that comes into our mind is regarding concentration. Right? Because when we go to a lab, we want to do any experiment with respect to solutions. The first thing is we think of is what is the concentration of the solution? Is it more concentrated? Is it more dilute? So in that case, there are different concentration terms that we're going to look at. And this is going to be same as what we did in the first year also. We will look at molarity, molality, mole fraction, mass percentage, and so on. So we will be solving problems in that, and the problems are very similar to what we did last year. Then we will move on to solubility of a solid in a liquid and solubility of a gas in a liquid. So when we want to prepare, say, a liquid or a solution, we will either dissolve solid in say a solvent. It could be just a salt in water, or it could be, say, any other compound that you want to dissolve in a solvent and you want to prepare a solution. Or you can just say that you want to prepare a liquid or a solution that contains gas as a solute in it. So in these cases, solubility is what we're looking at. Now when we learn about solubility, we're not only looking at how it is soluble, but we will also look at various factors that are responsible for this solubility. So say, for example, if I'm having a solute which is a solid and you're trying to dissolve it in liquid. Now when I try to increase temperature, when I try to decrease temperature, what is happening to the solubility? Because not all solutions are formed or completely soluble when you decrease the temperature or when you increase it. So in that cases, we will learn what are the factors affecting these. Similarly, when you look at solubility of a gas in a liquid, we're talking more about pressure, because gases are dealt always with pressure. Right? So when you reduce the pressure, when you increase the pressure, what is actually happening? You know, when you learn about increase and decrease in pressure and all of that, you will also learn something regarding endothermic exothermic reaction in relation to Le Chatelet's principle, which we learned last year under equilibrium chapter. Because whenever we deal with respect to increase or decrease in temperature or pressure, we also need to see if that particular reaction is endothermic or exothermic. So there we will come across again Le Chatelet's principle. Then we will learn about vapor pressure, because sometimes our solute is volatile. By the term volatile, I mean that when you keep anything open in air, it will evaporate. You don't have to heat it or anything, but it will evaporate by itself. For example, a very classic one that we can give is nail polish remover. I'm sure all of you will have this at home. So when you keep a nail polish remover open or a nail polish itself open, what will happen over time? The nail polish becomes dry, or the nail polish remover, the quantity will become lesser. So the same thing here also. When you look at, say, a volatile substance, you're trying to mix volatile substance, the vapor pressure will be different. Or if you're looking at substances which are non-volatile, but you're trying to dissolve it in a volatile solvent, there again the vapor pressure is going to vary. And both these are governed by some law. So we will come across those laws also in this chapter and problems related to it. Then you will come across a topic called as ideal non-ideal solution. So this is very similar to what we learned last year in states of matter chapter, where we only dealt with gases. So there, what did we learn? We learned something called as ideal gas. So that, what is that ideal gas? Ideal gas is something that obeys Boyle's law, Charles' law, Avogadro's law, and all of that. So same thing here, ideal solution also obeys certain law. That's why they're called as ideal solution. So the concept is very much same, but we are dealing with different types of laws in this case with different factors. Non-ideal solution again is something that do not obey it. So we will again learn classifications under that. What is the reason that they don't obey? Why is there a deviation from that behavior? All of that we will be learning. Then the last few topics are going to be based on colligative property and determination of molar mass. Now, what is this colligative property? There are some properties which are completely dependent on the solute particles, on the number of solute particles. So, if there are some properties which are dependent on the number of solute particles, those are the 4 types that we are going to study in detail. Basically, problem-oriented topic this colligative property, and there are 4 properties that we will be coming across: relative lowering of vapor pressure, elevation and boiling point, depression and freezing point, and osmosis. So these are the colligative properties we are going to study. Of course, there are more, but our syllabus is going to be restricted to only these 4. Now, this colligative property, please keep in mind, it is a problem-oriented topic. So, in your board exam paper for PUC, this is a compulsory question. A 3-mark or a 4-mark problem on colligative property will be there. Alright, now the last bit is abnormal molar mass. So these are a few topics that you will come across in this entire chapter, which we will be covering in each video. So let's move into the very first topic, which is the basic introduction before we move into any concept. So here, when we talk about solution, what we're going to talk about is a homogeneous mixture, right? For example, if you take salt and water, you're getting a solution, a salt solution, because the solute being salt is going to be dissolved completely in that solvent. Alright, or if you're taking, say, for example, the ones that you do in practicals itself, amorphous solid. You take that amorphous salt and you dissolve it in dilute HCl. What is happening? You're getting a clear solution. So a solution is basically a homogeneous mixture of 2 or more substances or component. A solution doesn't really mean that you need to have only 2 components. It can have more also. The classic example is when we're doing salt analysis itself. In the basic radical, say your radical is present in group, say 4 or 5. But before that, what are the things that you're adding? You have salt, you have water, and you're also adding NH4Cl, solid, and you're adding NH4OH. When you mix it, if you don't have a precipitate, you're getting a clear solution. That is a solution there. But is it having only 2 components? No, it has got 4 components. It has your salt that you're supposed to analyze. It has water in it. It has NH4Cl solid that's dissolved, and then you'll have NH4OH excess also. So that way we have 4 solutions, 4 components, I can say, to prepare a solution. So solution doesn't really mean that you need to have only 2 components in it. It can have more than that also. So what are these solutions called when they have 2, 3 components and all? So when the solutions have only 2 components, such kind of solutions are called as binary solutions. Example is salt in water. But what about when it had 3 components? If it has 3 components, it is called as a ternary solution. So in this case, you can call a solution of ethanol, ethanoic acid, and water. So when you have all 3 of them, that means you have 3 components. One is ethanol, second is ethanoic acid, and the third one is going to be water. So that is going to be a ternary solution. Alright. Now, the next one is expressing concentration of solutions. So just like how I've told you, when we talk about solutions, the very first thing that comes into our mind is what is the concentration of that particular solution. When you come to lab also, I give you, say, a beaker of some solution. First thing that you will ask me before you do any experiment is, ma'am, is this having any concentration? Right? So same thing here. Whenever you talk about solution, the very first thing that we're going to study is about concentration of solutions. So before we move into the problems related to it, we will be looking at what are the different types of concentration terms and its formula. So the very first thing is mass percentage. Now, just like how you find your marks in your exam, how do you calculate the percentage there? Whatever marks you got divided by total marks into 100. Same thing here. In this, mass of that particular component you want to find divided by total mass of all the components into 100. So it's just like calculating your board exam marks. The same thing with respect to volume. What is the volume of that particular component you want to find? Divided by total volume of the solution into 100. Now the next one is parts per million. In this, number of parts of component divided by total number of parts into 10 to the power 6. This is important. Please do not write 100. It is 10 to the power 6. Now, the next one is mole fraction. Mole fraction is again something that we did last year also. It is number of moles of one component divided by total number of moles of all components. We will be doing problems related to it, so it will be easier for us to know it. Then the next one we have is molarity. Number of moles of solute by volume of solution in liter. This is very important because our volume should be converted to liters. And the last one is going to be molality. In this case, it's number of moles of solute by mass of solvent in kilogram. So there are two things to be taken care of when you have molarity or molality. Molarity is for volume, molality is for mass. Whereas molarity is looking at volume of solution, the entire thing together. Whereas molality is talking about just the mass of solvent. Alright. And molarity, the volume has to be in liters. Molality, the mass has to be in kilogram. So now out of these entire concentration terms, only the last three we will have problems in it based on your NCERT textbook. The other three, the first three, we don't have problems at all. So we will only focus on these problems that are there in the last three: mole fraction, molarity and molality. Alright, so now let's move into the problem. The first problem says calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. So first thing is, the question clearly asks you to calculate mole fraction. And the value given to you, there is 20% of ethylene glycol by mass. So first, since the values are not given grams, we need to first convert that percentage to grams. So in this case, we are going to take mass of the solution is taken as 100. Alright, out of that 100, 20 grams is going to be for ethylene glycol. That's what is mentioned here. The remaining is going to be the mass of the solvent, which is 80 grams. So this is what is given to us in the question. Now, when you look at your mole fraction formula, it clearly says number of moles of solute by volume by total number of moles of the entire solution. Now, when it says number of moles, you need to get what is the given mass in it and what is the molar mass. So what you do, you first have to go from scratch. You calculate the molar mass of ethylene glycol first. So here I have ethylene glycol. The formula is given to you in the question. You have 2 carbon atoms, so it's going to be 12 into 2 plus 6 hydrogen atoms, so 1 into 6 plus 2 oxygen atoms, so it is going to be 16 into 2. When I calculate this, the final answer for mass of ethylene glycol is going to be 62. Then we need to find out what is the number of moles of ethylene glycol. So in this case, number of moles is given weight by molar mass. Given weight is there in the question itself. Molar mass is what we just calculated. When you substitute, you will get 0.3225 moles. Now, what is the solvent? It clearly says that ethylene glycol in a solution, so it has to be water. So here, when you try to find out same way, number of moles of water, 80 grams is what is given to us over here, mass of solvent, divided by, when we calculate the molar mass of water, it is going to be 80. So when we simplify this, you are going to get number of moles of water as 4.44 moles. So now that you know number of moles of ethylene glycol and number of moles of water, you just have to substitute this in the mole fraction formula. Mole fraction is always designated as a small x and number of moles is given as small n. Now in this case, the question clearly says calculate the mole fraction of ethylene glycol. So in this case, mole fraction of ethylene glycol is equal to number of moles of ethylene glycol divided by total number of moles of the entire solution. So here, number of moles of ethylene glycol we calculated 0.3225, that's in the numerator, divided by, we add up both the values in the denominator, because in the denominator it says total number of moles in the solution. Once you do this, once you've substituted it, you have to calculate this entire thing and you'll get your answer as 0.0676 as the mole fraction of ethylene glycol. So that is your answer for this particular question that says calculate the mole fraction of ethylene glycol in a solution. You start with molar mass, then you calculate what is number of moles, and then you put the values into the mole fraction formula to get your answer. So it's a 3-step process. Molar mass, number of moles, and then mole fraction. Now, the next question is again based on mole fraction, similar way, which says calculate the mole fraction of benzene in a solution containing 30% by mass of benzene in CCl4. So same thing here, let's write down what's given to us. So in this case, mass of solution as standard is taken as 100 grams. Mass of benzene is taken as 30 grams because it says 30% of mass of benzene. So it says 30 grams. The remaining is going to be for CCl4. Same method, because we don't have any other value, you start with molar mass of benzene and molar mass of CCl4. So here benzene is C6H6. So 12 into 6 here plus 1 into 6, which will give you 78 grams of molar mass of benzene. Similarly, when we do for CCl4, 1 atom of carbon, which is 12, and then 4 atoms of Cl, which is 35.5 into 4, 35.5 is the atomic mass of chlorine. When we do that, we get the molar mass of CCl4 to be 154. So we know what's the molar mass of both, and given mass is given over here from the question. Therefore, we can calculate what is number of moles of both. So number of moles of benzene is given mass by molar mass. Given mass is 30 grams, molar mass is 78 grams. When we substitute it, you will get 0.3846 moles. Now same way when we try to calculate for number of moles of CCl4, CCl4 given mass is 70, molar mass is 154. When we substitute both, you will get 0.4545. Now we have what is the number of moles. It's easy for us. You just have to substitute these values in the mole fraction formula. So here mole fraction of benzene is equal to number of moles of benzene divided by number of moles of benzene plus number of moles of CCl4. To substitute these value into the formula. Now when you substitute it in the numerator, you get 0.3846, which is the number of moles of benzene, and in the denominator you will get the both the values added up. This is equal to 0.4583. Mole fraction does not have any SI unit. Alright, so mole fraction as such, it is a very simple problem. All that you have to do is start from the molar mass, calculation of molar mass, then you move to number of moles, and then you move to mole fraction. Now the next question is based on molarity. So it says calculate the molarity of a solution containing 5 grams of NaOH in 450 ml of solution. So here before we move into it, let's write the formula and what's given to us. What is the formula? The question clearly says molarity. So formula of molarity is number of moles of solute by volume of solution in liters. Now based on the formula, we don't have number of moles given to us directly. So to calculate that number of moles, first thing we need is molar mass of NaOH. That's more important. So here molar mass of NaOH is Na is 23, oxygen is 16, hydrogen is 1. When we calculate, we are getting 40 grams of NaOH, which is the molar mass. So from this, we can calculate what is number of moles. So number of moles of NaOH is equal to given mass by molar mass. What is the given mass? 5 grams of NaOH is mentioned clearly in the question. So it's going to be 5 divided by 40, which is the molar mass of NaOH. You will get 0.125 mole. Now that you know what is the numerator part of it, the denominator is volume of solution in liters. Whereas volume here mentioned to us is 450 ml. The formula clearly says convert it to liters. So 450 divided by 1000 when you convert it to liters. So you will get 0.45. So in the molarity formula, instead of number of moles of solute in the numerator, you have to substitute 0.125. And in the denominator, instead of having 450 ml, you are going to substitute with 0.45 liters. Now when you calculate both of this, you will get what your molarity is, which is 0.277 mole per liter. So it's a very simple formula question. Again, for this also, you have to start from the calculation of molar mass, then you move to number of moles, and the last is going to be calculation of molarity. Now the last problem is based on calculation of molality. It's a similar type of a question when compared to molarity. So the question says calculate the molality of 2.5 grams of ethanoic acid and 75 grams of benzene. So in this case, the solute is ethanoic acid, solvent is going to be benzene. So here when you write the formula, molality is number of moles of solute by mass of solvent in kilogram. So in this case also, first what you do is you're going to follow the same pattern as problem number 3. Start calculating the molar mass of ethanoic acid. Ethanoic acid is nothing but acetic acid itself, CH3COOH. When we calculate the mass of ethanoic acid, you will get 60 grams of ethanoic acid. Now that you know what is a molar mass, it's easy for us because we need to calculate what is the number of moles of it. So given weight is given to us in the question, which is 2.5. Molar mass is given to us, which is 60 grams. When you calculate this, you will get 0.0416 moles, which is the number of moles of ethanoic acid. Mass of solvent in kilogram is given, but here it's given in grams. So in this case, when you divide it by 1000, it will be 0.075 grams. Directly substitute number of moles and the mass of solvent, which is converted to kilogram. You will get your answer as 0.554 mole per kilogram. So in this case, it's a very simple problem. So basically what you can do is just brush up those questions that you learnt in chapter 1 in 11th grade. So it becomes easy for you to solve these type of questions. So I hope this video has been helpful to you all. If you have any further suggestions or any comments, please put it down in the comment box below, or you can write it to the email an email to me to the email ID given in the description box below. I'll see you in my next video. Thank you so much for watching.